Welcome everyone. Today's edition of the distribution demo will include showing how to get proxy protocol to work correctly, either in an environment such as AWS or any other case where you're using Kubernetes for the deployment. There's some intricacies that need to be aware of, and we're going to explore what the methods are to get these configured in a way that functions appropriately. We have an existing issue from a customer where they're making use of EKS and they're saying that they're losing the client IP address. Now, this is not exactly uncommon, but you need to understand the difference between how GKE operates by default and how EKS operates by default. Our Nginx operates as a service with a load balancer address. In GKE, we're actually handed a direct cloud IP. In EKS, we're instead actually handed a NLB or an ELB, a load balancer instance, not a direct elastic IP address. You can get it to do that, but that's not what it does by default. As a result, those load balancers actually, if not properly configured inside the application, will do termination and proxying. Now, why does this matter? That means that you have a different address submitting the request, right? So your web browser hits that ELB, the ELB adds headers to HTTP requests and then forwards that down to Nginx. Properly configured, this means that Nginx will see that and trust those ELBs and then pass that additional header down to the application. Very commonly, instead of using X-forwarded for, you want to turn on proxy protocol, specifically proxy protocol v2, which is, as shown here, service beta Kubernetes IO, and then you set the proxy protocol. Literally, you just provide this with star and it turns it on. It's on or it's off. Now, the problem with this is, in order to get proxy protocol to work, you actually turn it on all ports or no ports. You can't set it on a given port. When you're doing this with an NLB, that means your HTTP requests now get the proxy protocol header inserted on them. But it also means that SSH connections, the TCP raw socket, gets terminated, a header is added, and then the traffic is passed. The problem is that that traffic goes to Nginx. Nginx goes, oh, this is TCP. I'm going to send it over to those services. And that header is still attached. And now it sends that header off to SSH. We're using OpenSSH, SSHD. That implementation is exact to the protocol definition of the RFCs, which means proxy protocol is not implemented. So when it sees the proxy protocol header in front of the TCP connection, it literally goes, I don't know who you are or what you're talking about. This is not my handshake. Go away, and terminates the connection. So if you turn on proxy protocols so that you're getting more accurate client IP information to your application, SSH now breaks for everybody unless you add a small change. Now, this issue has been open for a little bit, and the description is a little off on what the target audience actually is. The problem, as I said, is not that you can't get the application's HTTP responses to be recorded with the correct IP address. It's that when you do, you actually break SSH, which is the most common usage for GET. Someone came along and said that you can actually use :proxy at the end. And admittedly, if you read the paragraph that describes this, it doesn't exactly make it clear what the proper behaviors are, or what they do, or how exactly it works. It's literally saying these are two optionals, add one or both. Doesn't say what the right values are, how do you add it as a terminator, how do you add it as a proxy path, and what the effects of the various things are. Well, with a candidate yesterday, we actually went on a deep dive into how this actually works because of how vague that was. what we found deep in the settings controls of the Nginx ingress controller itself was the actual definition of what this format should be. And then we looked through the logic present there and found that essentially you take this string and you split it on colons. If you have 3 entries or more, the next entry is compared by string to the word proxy. If that's the case, Nginx will terminate proxy protocol v2, meaning it will read and strip the header. Thus, you can actually get it to take that off and then pass the rest of the TCP connection over to SSH. If you add proxy to the second optional field, it will now add that proxy protocol header back. So it will take it off from its own termination and then add it before it passes it on. Right? Now, the point here, though, is for those instances where it's coming in, you need to strip it off for SSH because of how we're currently using OpenSSH. If you turn this on, it will break because Nginx is looking for a proxy protocol header and it's not there. So in GKE, which unfortunately I'm having an issue with my environment at the moment, if you add this to the TCP definition, it will break incoming SSH, but it will not necessarily break HTTP. This is due to how TCP versus HTTP is handled as a part of Nginx. With adding the TLS load balancer as a part of AWS, you are in the opposite condition. You needed to do that termination and then pass on the raw socket content to the destination. So what I'm going to do here is take an existing instance that we have deployed, edit the service for the Nginx to add the annotation that tells AWS to do this with proxy v2, and then I'm going to edit the config map for the SSH on that particular instance and tell it to add proxy protocol termination so that we can see what happens when SSH traffic is passed through this load balancer with and without the SSH traffic having that header in front of it, and where the add and remove occur. So I have an existing install here. I'm going to just go ahead and create myself a quick project so that I have something to actually clone. Wow, I can type. Okay, blank project. Yep, I do need to add some SSH keys. Gonna grab this one. Clear all the many things I need to click away on. Hit clone. Okay. So I now can show that I'm actually able to do this and I don't have any problems with the logs. So I'm going to go over to my pods and I'm going to go find my Nginx ingress controllers and get myself some logs from this. Oh. It's of course going to the other one. And you'll see logs like this come across, TCP 200 and the messages. So now that I have that in play, I'm going to go over to the service definition for the Nginx ingress controller, edit that, and I'm going to add in the annotation that will turn on proxy protocol. Now I do also have to do a change to the Nginx config. Now I'm doing it in this fashion because we don't have any of this currently implemented in the chart. Okay. Now I'll see a reload. You can see here. And now if I try to do a git pull, I get a connection closed. So if I say git at and we can see that we sent the message to try and do that, but the connection got refused, right? If I come over into the logs, I see this, receive failed, because it's now trying to inject headers that the protocol doesn't understand. If I were to pop into the SSH daemon, you'd see nothing. So what I'm going to do is I'm now going to go edit the TCP ingress config map and add just this little bit of :proxy. Here we are. And here's our definition. And I'm going to add :proxy. This is technically case insensitive because the code that does the check runs to upper on the string. And we're going to end up seeing another reload. This time we can see that we actually get a full connection through, and we're able to do everything there. Now, I'm going to stop the scroll here, see if I can find, that's the reload. So let's go to the other container, pull up the logs and stop the scroll. Here we are. Now, you'll notice that shows the IP address coming from the load balancer, right? One of the things I did not do, it was add this in. I didn't add the VPC seeder for the real IP address. So there's still some configuration that I need to do. Now, I'm going to go over to GitLab shell. And you'll see that we see the connection but it's coming from just the IP address from inside of the network. Now, if I go figure out where this is coming from, I'll bet you that this is one of the two Nginx pods. This is the point where proxy protocol doesn't change the fact that SSH can't tell where the originator is because the protocol for SSH does not support this. Okay, so now, while if I go into the logs for web service, I can see that this is my IP address. The addresses that are coming through, reduce this by turning off scroll for a second. The addresses that are going to be coming through from the client do show up as external addresses, actual external addresses as correct. SSH can't because of this protocol difference. What us adding this level of functionality does is it supports the rest of the system being able to ensure that they get the correct client IP addresses. This does not directly address the problem of SSH not supporting proxy protocol. That has to be done through an extension to the SSH server, either by replacing it with one that does support it or putting some sort of extra port wrapper on it that does some fun termination. And the way that we've chosen to do this going forward is to actually implement an SSH server in GitLab shell, so that instead of having SSHD terminate the connection and then make the calls into GitLab shell, we're instead having a server that is GitLab shell that answers and speaks the protocol, understands proxy protocol v2, and then directly makes the calls that you would through GitLab shell, basically creating it into a single process container that has everything involved. That work, however, is going to be at least a quarter to get completely in and tested. I was intending to show you what happens if you turn this on in an environment where it doesn't work. AKA, if I did it in GKE and I turned on just :proxy, what you would end up having is, because there's no proxy protocol header involved on the way down, because it's directly exposed cloud IP address, everything goes whack, to say the least, because now it's expecting a header that's just literally not present on any connection that comes in. So you would actually be reversing the problem in GKE or another environment where you're directly exposing the IP address through a load balancer. You would just break SSH. Now, in the future, when the SSH daemon that we're using supports proxy protocol v2, we will actually want to investigate exposing the second proxy, because that is our daemon, our proxy, adding the proxy protocol, so that we're not directly passing, so that SSH doesn't see the proxy IP address as the client address. At that point, any string that is not precisely the word proxy disables that functionality. So once we have that in play, we'll actually change this in GKE to be :no proxy :proxy. And then the SSH daemon that we're running will actually get the IP address that Nginx saw when it passes the traffic across. There is a drawback I do want to point out. In doing this, with involving proxy protocol v2 in Nginx, it now has to fully terminate the connections and then pass the data. So when you do a push, it's going to be a small amount slower, because you're reading the data off and then passing the data back on. And it's not quite as simple as byte in, byte out. So on the plus side, once the connection is formed, the performance is fairly good, but the initial connection time is impacted in a small way. Does anybody have any questions or thoughts?
In terms of adding, excuse me, in terms of adding support for it, like how much of that falls into, I guess, distributions wheelhouse versus other teams, and then assuming there are other teams, feels like we need to get our arms around what all needs to happen.
So the good news is I've already been speaking with the teams responsible for GitLab shell for some time. And we're already in process and have merged basically an alpha level SSH daemon into the GitLab pages binary sources. So the project itself, you can now generate a GitLab shell SSH that actually is the SSH server with the GitLab shell binaries, the API literally built into the binary, so it doesn't have to spawn processes. Okay. The problem is there's more work yet to be done. So while that functionality is in place, we now need to make sure that we're injecting the proxy protocol v2 handling. We have to test that. We have to run it through security. There's more work to actually be done here. Let me scroll up. So I'm going to grab this issue here. And you can see there's a one from an issue related to this from infrastructure, because obviously we want this fixed too. And then we have the issue within GitLab shell to implement this. If we go in here, we have a link to a epic that actually has the GA epic for this GitLab SSHD. We have 394 merged, which is the implementation of this. And then we have to bring that in and add that full support within this. And this is not currently scheduled, and they're trying to figure out exactly when and how this actually will come into play. So I
Gotcha.
can trade further down, but production is involved because this is something that we need. The teams responsible for GitLab shell are involved. They're actively working towards this, and we have a roadmap from one of our staff engineers that's going to make sure that this is a viable option come this time next year. So if I click here, the current target is by, that seems a little off on this. But we have to get through all of these items in the epic before we considered it actually GA for this daemon itself. A lot of that has to do with making sure that we're very good with how it's actually outputting logs and everything else and all the functionality. When it comes to what we need to do is we need to have the ability to expose these settings. We very easily have the ability to set the config for the Nginx controller. We have the ability to set the annotations on the service for Nginx. Those are all good. What we need to do is to implement, according to our practices, a way to insert this information about TCP protocol proxying. Now, there is already an existing community MR for this, but we need to go over this carefully, because if we're not 100% sure of how this works and don't clearly document it, there's going to be bug reports, most likely due to configuration or misunderstanding of environment behaviors, things like this. This is a alteration to the way the TCP socket itself is handled. You do not botch that in a network situation, to say the least. So I want to say thank you to Philippe for the MR. We have not yet had time to go into it in depth, but also understand that we're going to be very specific about this one because we got to do it right.
Gotcha. Thanks for all that great context. I think that helps kind of lay the groundwork underneath.
Any other comments or questions? Seeing a couple of head shakes. Can't see everybody, so there I hit stop share. Nope. Okay, then despite my inability to get GK to cooperate with me today, because who knows, that I would say that was fairly successful in walking through the impact of what this setting actually does in the underlying Kubernetes and how it actually works. So I would say pretty good. We've got a little bit of work to do. I would say, I think we can get this one, at least the setting of the value, scheduled into 1310. I mean, hey, we got a community MR. We may get it done before the end of 13.9. I mean, cross our fingers, right?
Gotcha.
All right. Then thanks everybody for coming and have a good day.
Thank you, Jason.